Okay, so here we have continuation of the last video being rules and shortcuts to find y prime. And I'll do several videos in this series. They won't all be a continuation of the very first one, but at least for this one, I need to show you a few more rules before we have all the rules that we need for now. Okay? All right, now, so let's look at this one. This one says, suppose y is some constant times some function of x, some constant times some formula. You find y prime this way. You find the derivative of that, however you would do that, and then you multiply it by the constant. So in other words, you just carry the constant into the answer. All right? So it's a fairly simple rule. It might not be that surprising to you. Let's see it in action right here. Okay, so suppose y is 7 times x to the 4th power. All I'm saying is that the answer is 7 times whatever the derivative of x to the 4th power is. So what's the derivative of x to the 4th power? Well, in the other video, we learned this rule. If y is x to the n power, n being any constant, y prime is n times x to the power n minus 1. So, all right, the derivative of that x to the 4th power, that's going to be 4 times x to the 3rd power. Okay, so it's pretty easy to deal with constants when you have them like this, if it's a constant times a function. We'll just carry it along. Okay, so what's my answer going to be? Well, I got a 7 times a 4 times the x to the 3rd power. This is all multiplied together. I just put this in the parentheses to emphasize that I'm just bringing the 7 down, and here's the derivative of that thing, and that's what that rule said to do. I'm just writing it that way for emphasis. But 7 times 4, that's 28, and then we've got x to the 3rd power. Okay, and that's the way that we want it to be. All right, so new rule. Now you've seen it work out. Let's look at another one. Does this one fit into that rule? Okay, I got 6 divided by root x. I noticed that the way I gave this rule, it says you get a constant times some function, some formula of x. This is not a constant times some function or formula of x, but we could work on it like this. Now this could be more detailed than you need to show, but I'm going to assume when I can that you need to see the detail. Could I take this apart that way? So I could do that. What justifies me being able to do that? Well, when you multiply fractions together, you multiply straight across, and this would in fact multiply back together to give you that. Okay? And then we saw elsewhere in the last video, I have a way to rewrite this. So that's 6 over 1. That's going to be 6. 1 over root x is going to be x to the negative 1/2 power. Okay? So that's the way that I needed to see it. That is what looks like a constant times some function of x. All right. So we're getting to this point in order to work the problem. So what's y prime? Well, what do you do with the 6? Not much. You don't do much with the 6. You carry it down. Okay. And then I multiply 6 times the derivative of x to the minus 1/2 power. So that would be minus 1/2 x. And this would be minus 3 over 2 because I'm supposed to subtract 1 from that power. So I bring the 1/2 down there, and I take negative 1/2 minus 1. All right? That's what gives me negative 3 over 2. Okay, I see that all this is multiplied together. 6 times negative 1/2 times x to the negative 3 over 2. So, okay, that ends up being negative 3, right? 6 times negative 1/2. Then I've got this x to the negative 3 over 2. And maybe that's okay. That's for the most part, a perfectly good answer. It might depend on who you're talking to, or if you're doing online homework, what form of the answer it's going to accept, but there you go. Couldn't I also do like this? Because that's how we understand negative exponents. Okay. And couldn't I also do like this? Or it's like, let's do negative, and we'll do 3. I could, like, in fact, pull that negative out here because this fraction being a negative is equivalent to just the numerator being a negative. I could do like that. And this x with that fractional power is the square root of x to the 3rd power. Okay? So I said this in the other video, but you should be familiar with all 3 forms that answer could take. We have this flexibility given the meaning of negative exponents and fractional exponents. It's just a matter of fact about it. There's a lot of ways that you could write the answer. Okay, so let's try this one now. So what's this say? 4 times pi to the 9th power. Okay, are you inclined to do the problem this way? You say, well, 4 is a constant. Pi to the 9th power, that kind of looks like x to the 4th power. And so are you inclined to do this? I'm just curious. Is that what you feel like you would do? Well, no, I hope not. I mean, but, you know, if that's a mistake, it's an honest mistake. What's wrong with this? Isn't pi a constant? Pi is roughly 3.14. It is a constant. It's a known fixed number. It's not like x, which can take different values. It is definitely a constant. All right. So, well, what is this? This whole thing is a constant. You know, you take 3.14, you take it to the 9th power, you're going to get some number. You multiply it by 4, you're going to get another number. They're all going to be constants. What did we say the derivative of a constant was? It actually hurt to write that down. You know, that's definitely not right. I'm afraid that's what people would do just because it seems right and it kind of feels like the others. We said in the other videos that the derivative of a constant like that is going to be 0. Okay. So yeah, don't be fooled by the way things look. You got to think about the way things really are, not the way that they look. All right? Okay, so here I said the derivative of a constant was 0. Some people will get confused at this point. They'll say, wait a second, k there is a constant. And you said carry it into the answer, right? Multiply k times f prime, the derivative of f. Well, that's what you do with a constant when it's like that. But this is not a constant times something with x in it, all right? Okay, but so that's just not the way it is. It's just a constant all by itself. If you could draw this graph, it would be a horizontal line, and it would have a slope of 0, okay? All right. Now, so maybe something that looks a little bit different. Let's compare real quick and consider another example. What if you had y is equal to pi times x squared? Well, similar but different, okay? Pi is a constant times x. X is a variable. X squared is some function of x. That is what's like this. This one is not. Okay? All right, so what do we do? Well, pi is that constant. We will carry that down. So I'll get pi like so. And then the derivative of x squared is 2x to the 1st power, right? So let's write like this. Let's write this way. Let's say pi times 2. Well, it's a little bit more customary to write 2 pi. And then times x to the 1st power. Okay, so there. Now, so you saw maybe one that was fooled you a little bit, but you learned the right way to do it, and you can tell the difference between the two of these, okay? All right, so let's do some others with another rule. Okay, so look at that rule. It says, suppose y is one function plus or minus another. So I wrote it down there. It's function f plus or minus function g. A formula that involves x in it. And I guess this rule is about what do you do when you have addition or subtraction of functions? How do you find the derivative then? The addition and subtraction really doesn't influence much. You just carry it into the answer. If y is f plus or minus g, y prime is f prime, the derivative of f, whatever that is, plus or minus accordingly g prime, the derivative of g. Okay? Now, here's an example with pluses and minuses, and all I'm saying you're going to do is you carry them down. You find the derivative of these parts individually. Okay? All right. So let's do a little rewriting of this because I want to make it all fit that rule. You know, this rule right here. And having 1 over x doesn't really help us. Okay? So what is 1 over x? That would be x to the minus 1 power plus x to the 9th power minus 4. Okay? All right. So I take the derivative of this, I add it to the derivative of this, and I subtract the derivative of that. I work on these individually. Okay? All right. So here it goes. Y prime is... what's the derivative of x to the minus 1 power? That'd be minus 1 times x to the minus 2 power. Okay? What do I do with the plus? Well, I carry that down. What's the derivative of x to the 9th power? That would be 9 times x to the 8th power. Okay? Then this minus, what do I do with that? Carry that down. What's the derivative of 4? Well, 4 is a constant. What's the derivative of a constant all by itself? So that was addressed in another video, but it was also addressed here. The derivative of a constant all by itself. You know, this is not 4x. This is just 4. Is 0. Okay? All right, so we could give this answer negative x to the minus 2 power plus 9x to the 8th power. And that would be okay. Other form the answer could take. What about that negative exponent? Is there a way to write that? We could say negative 1 over x squared. I got a negative, okay. This term is negative. 1 over x squared with that exponent positive plus 9 times x to the 8th power. All right. And there we go. Okay. So, do you see the rule in effect, though? Do you see how we handle additions and subtractions? We just work on each individual part, whatever the rule is. Now, the rule for taking the derivative of x to the 9th power is different than the rule for taking the derivative of just that constant. They have different rules, okay? X to a power is different than a constant. So we just take case-by-case basis. Whatever we encounter, we use the rule that we need for that. So let's do one that is a combination of, what if you had a constant times a function, but then you had different functions added and subtracted all together, like this, okay? All right, so let's do this way. First, a little rewriting. I'm okay with everything here except for that second term right there. Okay, so let's go. We'll keep this 6x to the 2/3 power. I'm okay with that. For this one, let's do as I've done in other problems. We'll say this isn't 4 divided by root x. This is 4 times x to the negative 1/2 power. Okay, it would be the same thing, but that's I wanted to see it as what? I don't want to see 4 divided by some function of x. I want to see 4 times some function of x. Okay? So I've written it that way, and then I see my x has a power in addition to that, so I have a rule. Plus 7x plus 1. Okay? All right. So we'll work on this one function at a time. All right? So y prime. What did we say before when we had like a constant coefficient, like a constant times a function? What did we say you did with that constant? You carry it down. And then you multiply it by the derivative of this function of x, whatever that is. Well, that would be 2/3 x, and I got to subtract 1, so that'd be minus 1/3. So 2/3 minus 1 is 2/3 minus 3/3. All right. Carry down the 6. Derivative of x to the 2/3 power is right here. Now I have a subtraction. What do I do with that? Well, this rule says, well, you get functions plus or minus other functions. The pluses, the addition, the minuses, the subtractions. They just get carried down. You don't really do anything with that minus. Carry it down. What about the 4? It says 4 times. Oh, we carry that down too. Okay. What's the derivative of x to the minus 1/2 power? It's minus 1/2 x. What's that going to be? Take 1 away, so negative 3/2. Okay. And then 7x plus 1. Well, let's do this. I'm gonna pause this. I'm gonna say plus right here. Suppose I had another example. I'm gonna squeeze in here real quick. Suppose that y was just 7x. What would you say y prime was? Okay. Well, you would say that y prime tells you the slope of y, and 7x is just a line that has a slope of 7. So that's something I talked about in the first video I made in this series. So this is a line, this thing all by itself, not that whole thing up there. But when we get to just this term and we're trying to think about what the derivative is, then just that, just 7x, that's a line. Okay? And so, all right, it's a line with slope 7. Y prime is equal to 7. Okay? But, I see I have 7x plus 1. So what if you grouped all this together and you say, now, okay, I'd say plus 7x plus 1. Still a line, right? 7x plus 1 is a line with slope 7, intercept 1. Slope 7, y prime 7. So that part's just going to be 7. Okay? So you could look at it like that. The derivative of 7x is 7. Okay, given that it is a linear form. And then you could say the derivative of the constant was 0. You could do it that way. You could look at this whole last term there as 7x plus 7. Still a line with slope 7. Still you're going to get 7. Okay? All right, now I'll say a little bit more about that after I'm done with this one. But I'm more or less a comfortable spot with this one. Let me give you my answer. So I got 6 times 2/3, so that's going to be 4. Okay, I'm going to say 4x minus 1/3. Okay, and then here I have negative 4 times negative 1/2. That'll be positive 2x minus 2/3. Okay, and then I've got plus 7. All right, and that's all of it. Now, I know in the other problems, I've written the other forms that this can take with the negative exponents and the fractional exponents. I'm going to just leave this one as it is because my way of transforming that from this to this and so on is the same every time. And if you need more help on that, just reach out to me, but I'll leave this one here, even though I could write the answer different ways. Let's talk about this. This 7x deal, that could be a little tricky. You might not like the way that I did it. You might not like the way I came up with 7. Okay? So let's think of another way to look at it. Okay, so here's another way that you could look at it that would work for us. So say you got to the 7x and you're wondering how do you find the derivative of that? Okay? Can you use this rule that if y is equal to x to the n power, y prime is equal to n times x to the n minus 1 power? Is that rule operative here? Well, I guess so, because I could say this was 7x to the first power. There is a power there. There's an exponent, and it's a 1. So let's try this and see what we get. So y prime, all right. First, what do I do with the 7? Well, it's 7 times x to the first power. That's the case where I have a constant times some formula that involves x, some function of x. I carry that constant into my derivative. So I get 7. And then what's the derivative of x to the first power? Well, here's the rule that seems to apply to that. So we'll say, okay, power's 1, we bring the 1 here, and then we subtract 1 from it. That's the way the rule would be applied to this. So let's see, what's this going to be? 7 times x to the 0 power. And what's, I'll say like a number 2 to the 0 power, 3 to the 0 power, negative 6 to the 0 power. They're all going to be 1. That's what the 0 power does for us. So this is just going to be 7. All right. So yeah, you'll get 7, however you think about it, right? It's just really a matter of your preference. But I wanted you to see your options for figuring that out.